Welcome everyone. In this video I'm going to show you how you can find the coefficient of static friction of a surface by only using a protractor and a calculator. It sounds interesting, right? So let's get started. Let's say that we have an inclined plane like this one and we have a block on top of it with mass m. The coefficient of static friction of our surface, we call it mu s, and the inclination, the angle here, is going to be called theta. So we set up our coordinate system as well, just like we should do before starting every problem. We have x and y like this. So x is along the inclination and y is perpendicular to the inclined plane. So how can we proceed from this? The way I would do is by first drawing the forces that acts on our object. So we will have the normal force perpendicular to the surface. We will have the force of gravity, mg. We will have also the force of static friction up the incline. And notice that this angle right here will be theta as well, because if you complete this to a right triangle, you see that this angle is 90 degrees minus theta. So this one should be theta to make it to be its complementary angle, right? So let's erase these. We don't need them anymore. Great. Now let's write the force equations that we have for both directions. And I will start with the y direction, because why not? So we have n, and it is going to be balanced out by mg cosine of theta. Why is it that? Because on the y direction there will be no acceleration. Now the x direction is a little bit more interesting. So we will have mg sine of theta minus the force of static friction. This will be equal to 0 because at this point, the object, our mass, is at rest. Alright, so there is no acceleration, which means that the net force in any direction should be 0. Now, I want to remind you an important equation, and that is for the force of static friction. It says that force of static friction is less than or equal to the coefficient of static friction times the normal force. Now, for the force of static friction, we will still keep it like that, but for the other side of the inequality, we will substitute for the normal force this equation that we found, this expression actually. So we will substitute mg cosine of theta. And if we solve the force equation for the x direction, we can see that Fs is equal to mg sine of theta. Now we will substitute this for our inequality, and I'm going to do it here. So we have mg sine of theta is less than or equal to mu s mg cosine of theta. Right? Now, we see that m's here cancel. This means that if we were to have a heavier or a lighter mass, the result would not change. We also see that g's cancel. This means that if we were to do this experiment on the moon or on the Mars, we will still get the same results. And if we divide both sides by cosine of theta, this will be gone, and we will have cosine of theta like this. And sine of theta divided by cosine of theta, this is by definition equal to tangent of theta. So we found a very neat inequality, I would say, that states mu s is, well, actually let me write it the other way, which states that tangent of theta is less than or equal to the coefficient of static friction. Well, this is great, but how can we use this for calculating the coefficient of static friction. And I'm going to discuss the implications of this inequality on the new page. So we found that tangent of theta is less than or equal to, my bad, it is less than or equal to the, I can't write, I'm sorry, the coefficient of static friction. Now, we are interested in what happens to tangent of theta as theta increases. So, if we increase theta, how will tangent of theta change? Well, since theta is between 90 degrees and 0 degrees, this is because of physical reality. This is because of physical reality. This is representing an inclination. So, it should be between 0 degrees and 90 degrees. So since theta is between 0 and 90 degrees, this means that as we increase theta, sine of theta will increase and cosine of theta will decrease. Since tangent of theta is, as we argued here, is sine of theta divided by cosine of theta, the numerator will increase and the denominator will decrease. So the whole quotient will increase. So tangent of theta will increase. But we can't keep on increasing theta forever, right? At some point our block will start sliding. So there is some theta max that we can have. And this is going to correspond to a tangent max. Tangent theta max. This will be the maximum value that our tangent can get. And what is the maximum value of our tangent of theta if you look at our inequality here? Well, you guessed it, it is, so for tangent of theta max, we will get mu s. And boom, this is the formula that we will use to find the coefficient of static friction. Because the only thing that you need to do is to use a protractor to measure theta max. Theta max. Sorry, I'm really excited for this proof. That's why I confuse things. This is theta max. You measure theta max. Measure this. This is measured. How can you measure this? Well, you simply start at a low inclination and then you steadily increase the angle of inclination. The inclination, actually. You increase theta and at some point the block will start sliding. When it starts to slide, you stop increasing the angle and you measure that angle. You call it theta max. Then you just take its tangent using your calculator and boom, that value will give you coefficient of static friction of the inclined plane that you're using. I hope this is helpful and it makes sense. I really would like you to try this at home and to see if you can correctly determine the coefficient of static friction of different surfaces. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.